Hello and welcome. This is Bijan Hoshiar. I have created a switched network with multiple paths from any one switch to the other ones. And we want to observe how STP is going to operate in. Switches are switch 1, switch 2, switch 3, and switch 4. They have default configuration, meaning there is only VLAN 1 that exists on them, no other VLAN. Their priorities is the default value. Because of that, because the priorities are the same, the criteria that is being used to elect the root bridge is the lowest base MAC address of the switches. I have purposely turned the link lights off to explain this topology and how STP works, and then I'll turn them back on. I have already obtained the MAC addresses of the switches and I have written them alongside the switch name. The way that you can obtain the MAC address of a switch is by going to privilege mode and perform show version. When you do that, the base MAC address of the switch is going to be displayed. This is the base MAC address of switch 1, which I have written in here alongside switch 1. I have done the same thing for the other switches. Enable, show there. And you notice that the base MAC address of switch 2 is also copied right there. I've also performed show VLAN on all the switches, show VLAN, to verify that only VLAN 1 exists on these switches with all the switch ports in VLAN 1. So because the priorities are the same, the lowest base MAC address is going to be used to elect the root bridge by STP. When I compare the base MAC addresses of switch 1, switch 2, switch 3, and switch 4, notice that base MAC address of switch 2 is the lowest. The first 3 digits are zeros. The third digit is 4 for switch 1. The third digit is 6 for switch 4. And the third digit is hexadecimal E for switch 3. Therefore, this base MAC address is the lowest, which makes switch to the root bridge and the other 3 switches non-root bridges. I have connected switch 1 to switch 2 through their FA01 ports. I have connected switch 2 to switch 3 through their FA02 ports, connected switch 3 to switch 4 using their FA03 ports, and connecting switch 4 to switch 1 using FA04 ports. It doesn't matter which ports you use, I just want it to be consistent. Since switch 2 is a root bridge, both FA01 and FA02 of the switch 2 are in designated mode. Since the lowest cost path from switch 3 to root bridge is through this link, therefore FA02 of the switch 3 is the root port. Put it a little bit lower, like that. Okay. Since the lowest cost path from switch 1 to root bridge is through this link, therefore FA01 of the switch 1 is also a root port. Now we need to decide for switch 4 which one of the two ports, FA03 or FA04 of it, is going to be root port. It depends on the MAC address of the neighboring switches, which are considered as sender devices. We need to compare MAC address of switch 3 and switch 1 to see which one is the lower one. When we do that, 004 is less than 00E in hexadecimal. Therefore, FA04 of the switch 4 will become the root port. Now we need to decide which one of these two FA03s are going to be disabled in alternate mode, which one in designated mode. When we had a topology of 3 switches, we would make that decision based on base MAC addresses. In a scenario like this, that doesn't work. In order to find out which one of these two FA03s are going to remain open, this is FA03 by the way, are going to remain open, and which one is going to be in an alternate mode, we have to compare the burned in MAC addresses. Each port of a switch has a MAC address referred to as burned in MAC address. In order to obtain that, we need to go to the privilege mode and perform show interface FA03. The burned MAC address is going to be displayed, which I have written over there for switch 4. Let's do that for switch 3 as well. Enable show interface FA03. The burned in MAC address of it is displayed, which I have recorded over there. When I compare these two numbers, I'll notice that the burned in MAC address of switch 3 is a lower value. 000 is less than 005 in hexadecimal. Therefore, FA03 of switch 4 will be in alternate mode, and FA03 of the switch 3 will be in designated mode. This is also in designated. Now let's go ahead and turn the lights on, see if they can verify what we have decided. Yes. Let's further verify by performing some commands. Let's see if switch 2 is really the root bridge. We perform show a spanning dash tree. It says the priority of the root bridge and the priority of the switch to are the same. The base MAC address of the root bridge is the same as base MAC address of switch 2. Switch 2 is the root bridge. Another indication is that both FA01 and FA02 of the switch 2 are in designated. Let's do the same thing on switch 1, show span. Notice that priority of the root and switch 1 the same. That criteria is not used. Base MAC address of the root bridge, which in this case is switch 2, is less than base MAC address of switch 1. Switch 1 is non-root bridge, and another indication is that FA01 of it is in forwarding mode and it's a root port. FA04 of it is in forwarding mode, designated type of port, non-root bridge. If you perform the same thing on the other switches, let's say switch 4, show span, you'll notice that FA03 of it is in alternate mode, FA04 of it is root mode. The priority of the root bridge and switch 4 are the same. The MAC address of the root bridge is smaller than MAC address of the switch 4. So what we have discussed at the beginning without turning the lights on verifies. The only thing is that this link deciding on which of these two FA03s are going to be designated which one alternate mode is decided based on lower burned in MAC address of the FA03 interface. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.